Let's take a look at now at the idea of logarithmic and exponential functions with base other than e. We've looked at quite a bit at base e. Now it's time to get away from base e and take a look at the other possibilities. So like usual, here's the learning objectives, what we want to get out of these next several videos. First of all, we want to define exponential functions that have bases other than e. We want to be able to differentiate and integrate exponential functions that have bases other than e. And I want to be able to define and I want to be able to differentiate logarithmic functions bases with other than e. So let's start off with a definition. If b is a positive real number such that b is not equal to 1 and x is in R, which means this x is a real number, then the exponential function to base b, which is denoted by b to the x, is actually defined as b to the x is equal to e raised to the ln b all raised to the x, which is the same as e raised to the x times ln b, which of course you could also write as e raised to the x raised to the ln b. All these say exactly the same thing. So let's take a look at some properties of f of x equals b to the x. First of all, the domain of f of x is in fact negative infinity to infinity, which becomes very obvious if we graph this. B to the x looks like this. It looks just like e to the x. This is 1. Because it is a function of e to the x. Now the range of f of x will be just like it is for e to the x, 0 to infinity. And see, for all b greater than 0, b to the 0 will be equal to 1. And for all b greater than 1, b to the x is an increasing function, whereas for b between 0 and 1, b to the x is a decreasing function. What I drew here is something of the form b to the x for b greater than 0. If I have a situation where I have b to the x for 0 less than b less than 1, so the base is in between 0 and 1, it would be a decreasing function, so it would look more like this. Very commonly, we think of the increasing functions or make reference to them as exponential growth, and the decreasing functions as exponential decay.